Hello, Science 20s. Our lesson today is going to be on dilution. It's going to look at how we add water to dilute a substance to make it weaker, or possibly how we add less or remove more of the solute in order to make it more dilute or weaker as a concentration. If we take a look, most of us should already know that dilution is the process of decreasing the concentration of a solution. Usually we do this by adding more solvent, or for our benefit, adding more water. Think of it as you go into your freezer and you grab this Minute Maid orange juice. It's concentrated. When you pop the lid off and you pour it into the juice jug, the pitcher, you then are going to add a pile of water to it to get it to the concentration you want, a little bit weaker. When you were little, your parent might have popped the top off and let you lick that very concentrated little bit of juice on the lid, but you wouldn't want to eat the whole thing like that. That is very, very strong, very, very concentrated. So diluting, we can think of it as a way of adding water to decrease the concentration. Now, if we look at this example, we have an initial solution and a final solution. In between the two of these, we're going to add water. And you've seen this picture before. In my initial solution, I'm going to have 7 particles of my solute. In my final solution, I'm still going to have 7 particles of solute, but you'll notice the space between them is greater because we are adding more solvent. We can take the formula you already know, C equals N over V, concentration equals moles per volume, and we can move it around to solve for moles. This is going to be the moles we have before we started or added any more water. Once we add the water, this is going to be the moles we have afterwards. And there's a direct correlation between this initial and this final, this before and this after. And that's going to be the formula we look at today. And that's going to be this formula right here. So if I take a look at this formula, again, it's on page 10 of your data booklet. This means by now you should have highlighted all the formulas on the bottom of page 10. And if we take a look at the formula, it's CI, which is the initial concentration, and we can look at this in moles per liter, times VI, which is the initial volume. Again, if you want to look at it in liters, and that's going to equal the CF, final concentration, times the final volume. The trick to this is whatever your unit is for concentration for initial and final, they have to be the same concentration. So moles per liter, moles per liter. It could even be parts per million, although we're not going to use that one. Okay. Volume, again, can be the same volume as long as they are exactly the same. So it could be liter, liter, like I've written here, but it also could be milliliter, milliliter. The key is that they are exactly the same units for concentration and that they are the exact same units for volume so that they can cancel off. The one other thing I might add on here is I might actually show you how to move this formula around. So if the formula is CIVI equals CFVF, and let's say we want to solve for VI. Again, I want to get VI by itself, so I've got to move the initial concentration across the equal sign. Remember, when we move across the equal sign, it's going to change floors, so concentration is going to move down to the basement. So our formula is going to become initial volume equals final concentration times final volume divided by initial concentration. So it's going to change floors. And the whole formula works this exact same way. So what I'm going to do is I'm going to clear the slide. And what I would like us to do is let's try an example. So let's copy down the question. And if you feel comfortable, let's over on the left-hand side, make a list of the variables that we could be using. So I'm going to do this with you. So water is added to 200 milliliters. So that is my initial volume of 2.40 moles per liter ammonium cleaning solution. So this is going to be my initial concentration of the ammonium, 2.40 moles per liter, until we reach the final volume of 1,000 milliliters. So final volume is going to be 1,000 milliliters. We would like to know what is the molar concentration of the final diluted solution. So I want to find final concentration, what it is. Now, I look to just check my units, milliliters, milliliters. We like that. Moles per liter for concentration means my answer is going to come out in moles per liter. So, of course, you get your first mark for copying the formula out of your data booklet. CI/VI equals CF/VF. If I have anybody who's taking Chem 20, if you would like to do C1V1 equals C2V2, you are more than welcome to do that. So I'm going to circle CF because that's what we're solving for. To get final concentration by itself, final volume is going to have to go to the basement. So CF equals CI/VI over VF. You get 1 mark for the two formulas. You need the one out of your data booklet and you need the moved around formula. We're going to sub in our values. 2.40 moles per liter concentration. So that's times. And we're going to multiply it by our initial volume of 200 milliliters. And then we're going to divide our answer by our final volume, which is 1,000 milliliters. So in my calculator, I am going to go 2.40 times 200, enter, divided by 1,000. And the answer I get out is 0.480 moles per liter. You get your second mark for substituting in the numbers with unit attached, and you get your third mark for giving me the answer with a unit attached. This question would be out of 3 marks. Okay, I'm going to clear this. And we're going to go to the second question. What I would do in this question is I would copy the question, I would pause the video, I would then try it for myself, then unpause the video to make sure, along with me, that you are doing it correctly. Pause the video now, please. I have 65 milliliters, so that's my initial volume of 0.759 moles per liter solution of sodium chloride. Determine the final volume, so I'm going to find VF. When we diluted it to a concentration of 0.200 moles per liter. So I'm checking moles per liter, wonderful, same unit. Milliliters, that means my final volume will also be in milliliters. So I get 1 mark for copying the formula. CI/VI equals CF/VF. I am solving for VF this time, so I'm going to move concentration to the denominator on the other side. So VF equals CI/VI over CF. You get 1 mark for the two formulas, the original and the moved around version. We're going to sub in initial concentration, 0.759 moles per liter. We're going to multiply by that by the initial volume, which was 65 milliliters. We're going to divide the question by final concentration, 0.200 moles per liter. So when I go to type this into my calculator, we're going to take 0.759 times 65, enter, divided by 0.2, enter, and we're going to get 247 milliliters. Now, You get a mark for substitution with units and you get a mark for your answer. What I want us to do is, does your number make sense? So if we take a look, the concentration went from zero point 0.7 to zero point 0.2. So the concentration went down. It got less concentrated. Well, the only way your orange juice gets less concentrated is if I add more water. So if concentration goes down, volume should go up. So let's check my volume. I started with 65 milliliters. I now have 247 milliliters. My number makes sense. The nice thing about this dilution formula is it should make sense. Your numbers should correlate with what you already know. The beautiful thing about dilution is most of us, we're familiar with this already in our own houses and in our own homes. We dilute lots of things, right? You buy soup, sometimes you have to add a can of water or a can of milk. We're going to dilute the soup down. We do the juice crystals, we're going to dilute it down by adding water. So this kind of makes sense when we go to do it, especially even painting. You're going to dilute your paints down to get to some of those muter or softer colors. Hopefully this lesson works for you. Please don't forget to complete the worksheet.